Hi, everyone. We're going to do a little bit of practice on how to identify transformations with no information other than the figures on a two-dimensional plane. So what we're going to start with is eyeball test first. If I can't visibly tell what's going on, then the easiest way to do this is to take a pair of points and see what happens from my original to new. And this is without any rules in front of me. So I can see here that A is looking at A, B is looking at B. It looks like it's flipped over this line. And so I'm going to call this a reflection over X. But to double check, we're going to take a point. I'm going to take B. So my original B is -2, comma, -3. And that transforms to B prime, which is -2, +3. And I've already said before that if it's in the name, it stays the same. So X stayed the same and Y became opposite. So this says X comma Y becomes X comma -Y. Okay, so that's how we do that. So we take one point and see what happens from those originals on the figure, and we should be able to figure that out. All right, let's go on to the next one, number 2. So first one was a reflection over X. Number 2, this looks like a reflection, but remember our reflections are either over Y or X. So if I'm not sure what this is, and I'm going to guess that it's a 180-degree rotation, where this went one turn and then two turns like that. That's my guess. So I'm going to guess 180 degrees rotation. And then I'm going to double check with a point. So I'm going to look at H, and H is 4 comma 2, and H prime, new H, is -4 comma -2. We know that for 180 degrees, it goes from original to both sides, both X and Y becoming opposite versions of themselves, because that's what happened. +4, +2, -4, -2. This is a 180-degree rotation, confirmed. Okay. Let's look at 3. I and I, they look like they're in the same spot. This doesn't look like it has turned. J doesn't look like it's turned. It looks like it has slid down because the rotation 180 degrees. Notice the vertices are in different locations. So we are going to say that this slid. We're going to call this a slide. And this went to the left and up. Okay, so we're going to figure out how much left and up by picking a point. I could count on the grid by starting at I, ending at I prime like this. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8. So we went up 8, and then we went across 1, 2, 3, 4, 5, 6, 7, 8, 9. We went to the left 9. So we know that left is X minus. So we went left 9, which is minus. And we know we went up 8, which is plus. So this is a translation, and that tells me X minus 9, comma, Y plus 8. Okay? So far, remember, whatever we're doing, it's very easy to see what's happening with one point because we can't just move one point of the figure. Whatever we do to one point, we have to do to the entire thing. So let's look at number 4. So number 4, and we're almost done with this page. Number 4, we start in this quadrant. So this is quadrant 1, quadrant 2, quadrant 3, just to do a refresher, and this is quadrant 4. So we started in quadrant 3 and ended in quadrant 2, but it looks like it's turned. So it looks like it literally turned in this direction like that. and this is the clockwise direction, I would say this is a 90-degree turn. Okay, doesn't flip because if it was a reflection, these would be N would be facing N, L would be away from L. So I'm going to go 90-degree turn, 90-degree clockwise, and let's double check with our points. So let's take N. N is -4, -7, and N prime is -7, 4. Okay, so if I go down to my representation down here, and I'm moving this up just a little bit, algebraic representation says from my original xy, x and y change places, and then the x change signs because it went from -4 to +4. Okay, the -7 stayed the same, but the -4 turned to a +4. So that's what happened with that. X and Y flipped, and X stayed negative. Okay, so 90 degrees clockwise was confirmed. Let's see. Number 5, we have P, P, Q, Q, and I'm going in the wrong direction. Oh, no, I'm not. P is going to P, O is going to O, R is going to R. It looks like this is sliding in this direction. Didn't go up or down, but we're going to double check with our coordinates. So let's take P, because I like P. I'm going to go with slide, and we slid to the right. That's my guess. But to confirm, we have P, which is -7, 7. And we have P prime, which is 3, 7. This right here tells me that X and Y don't have the same values. That lets you know that it's not a rotation or a reflection. The only one that's going to make different numbers is a translation. So how much did it take for me to go from -7 to 3? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went 10 to the right, which will tell me X plus 10. And then Y didn't go up and down or down because it's both 7. So just Y. So my rule would be X plus 10, Y. Okay, last one on this page is the number 6. And this, if I had to guess, I would probably say a reflection because V is staring at V, U is staring at U. Anytime the letters are looking at each other like this, it's probably a reflection. And this is my Y line since it's vertical. So I'm going to say reflect over Y. So to prove that, we're going to take a point. Let's take V. Okay. V is 2, -2. And V prime is -2, -2. So what changed? The X changed and the Y stayed the same. So we went from X, Y, and the X changed, so that means it became opposite, and the Y stayed the same. That is a reflection over Y. Okay? So on this page, we went through reflection, rotation, translation, and another rotation. Hopefully, seeing this allows you to figure out what's going on graphically. On the next video, I'll do one where we're just using ordered pairs. Okay, and once again, like, comment, subscribe, share for more content. And hopefully, this is helping you out. Until next time, bye bye.